Okay, one more time. You guys told me this one is about 34 point what?
793.
Okay, good. Okay, so now I'm going to give you a harder one. You ready?
Yeah.
Remember, my pictures are not to scale. Okay?
Is it to the y-axis?
No, we're not ready for that yet. Okay. Great. Okay. This time, no.
Yeah, Curtis already out.
Okay. So this time, I want us. 34 point what?
793.
Okay. I want us to rotate around the line.
Oh.
Y equals -1. Okay, so this time my axis of rotation is y equals -1. This time over here, it was y equals 0, right? Because it was the x-axis. Okay? Now hold on, we're going to stick together. First of all, let's think about what this shape would look like. Okay? So it's going to have a plateau again, right? And the plateau over here, but is the plateau or the hole in this one, is it going to grow with the growth of this side of the shape? So should I draw it bigger?
Yes.
It's a rectangle here, right? So it's actually going to be like the same size.
Oh, just without.
Also, it's a bigger axis of rotation.
Right, because look, this is
Is it just hollow?
Is that what the washer?
not totally hollow.
Is that what the washer thing
Yeah,
is
that's
for?
where the washer's coming from, right? Because if I take this and I rotate it around
You're right.
the axis, where does this one's edge start? Maybe here? You with me? Do we have any runners in here? Okay, explain to me on a track why they have to stagger the start of the starting position of the runners.
Well, the people on the outside
Right.
are going to be running farther than the people on the inside.
Okay, and is there ever a track that the what is it, tar? Is it tar? It's not asphalt. What's the track made of? Can we say tar? If it's not tar, we just call it tar? Okay, so the tar for the track, right? Aubrey, does the tar for the track ever like if two runners are going opposite distances, are they ever gonna have the tar touch each other, or is there always something in the middle?
Wait,
I don't understand the question.
Is it just a full, filled oval? Or
Yeah.
is there like a track around?
But so okay, yeah, the question's not great. I'm asking, when you visualize a track, isn't there always like grass or a football field or something in the middle?
Yeah.
There has to be something in the middle. You with me? Has to be.
Otherwise,
Okay.
it's just a plane.
Otherwise, it's just a plane, right? And there might not even be any way to stagger it. But the point of what Aubrey's saying, the staggering is because the outer distance is longer. You with me? Okay, so keep that in mind. And I want to know, even though if this is the same shaded region, if I spin it around y equals -1, will the volume stay the same? No, it should be a bigger number, right? It should be a bigger number
What would it be?
because it's like the outside of the track. You with me? It's the outside of the track.
but we're still counting the inside too.
We're not on this one because this is the grassy area in between it, right?
It gets farther away.
It gets farther out. You with me?
All right.
Okay.
Take this.
And that offsets the hollow?
Huh?
The offsets.
That's why you know there's going to be a hollow tube in the middle of it.
Yeah, but doesn't that make it smaller? Because it's hollow? That's smaller.
But not the same amount, because what's happening is that, okay, so
So because it's
do you guys remember our discussion at the beginning where I asked you guys why you only drew in the first quadrant? Because anything below the spinning that's part of our shaded region takes away. So yeah, this hollows it out, but all it's doing is taking away what would have been here.
Creating more space on the outside.
If this part here is not even going to touch anything in here,
Yeah.
it's going to sweep away what I need to here.
It's just creating more space
Okay.
on the outside to compensate for the space on the inside.
There it is. Okay? Now let me ask you this. is the radius of my cylinders still ln of x?
No.
No.
What is it now?
Minus
Ln
one.
of x plus 1?
Plus 1, because it's a bigger radius,
Oh.
right? ln of x plus 1.
That makes more sense. I thought it was minus one.
So good, the f of
That's
x
what I did
minus
at first.
g of x.
Kind of. Okay, kind of. So let's try and set up this integral together. So where are the limits of this integral going to go to? 2 to 7 pi ln of x plus 1 squared dx. Is that okay?
I did something different, but I wanted to see her.
Everybody agree with that?
Yes.
I do.
I do not.
Man. Is it minus? Oh, there's a hollow. There's a hollow part. Take out the hollow.
Yeah, we got to take out the hollow part,
How do you do that?
right?
Oh, it's
We got to take out the hollow part. Right now, this would be just this, just bigger. We got to take out that middle cylinder.
So do we like divide it?
No, we minus.
Oh. I was thinking like making a whole.
Do we know the radius of the inner circle?
Yeah.
Nope. 1. Its diameter is 2.
Yeah, okay, yeah, really.
Right? Remember, the axis of rotation
First thing I
is
did
here. So this is 1, and this is ln of x. So what the radius of the inner circle is
Pi 1 squared.
1 dx.
Oh, that makes so much sense.
So basically, whatever you add on the inside also.
Yeah, my crappy drawings work better for Seth. Anybody else knowing that? That's crazy. These are crappy drawings.
Better than I can do.
Well, thank you. I appreciate that. What I mean is compared to the 3D prints of these actual objects that are in a big. Well, that's because rotational volume is easier than cross section
I
volume.
agree.
Yeah.
You just see it rotate.
Yeah.
in your head.
It's just a lot. Yeah, rotational volume is easier than cross section volume, which is why I did the cross section volume first. Okay. Yeah.
So I.
What'd you get? It's like 80 or something.
Yeah.
80.252.
80.252.
Yeah.
I
Okay.
did something a little bit different when I first was trying to think of like how I'd set this up, and it's really weird because it doesn't get the same answer.
It does or does not?
It does not.
Okay. So are you wondering why what you did is wrong?
Yes.
Can you write it out for me? And because the test is next time, I will look at it when I have a second. But I want to. I really want to get through the
No, you're
lesson.
totally good.
Is that okay? But write it out and don't let me forget to come back. But I'd love to help you. Okay. Okay. Now we got to do another one. Are you ready? Okay. Hurry! 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 Type it in.
Probably gonna go in a like a positive direction.
You're taking a bunch of. So what you think about it is you just take like 100 billion of these cross sections, so stack them next to each other, and you need more to fill in this shape than you would need of the other one. Yeah, that's great. Okay. Okay. Now here's the next one. Okay. This one is gonna be a little different, but I'm trying to get you to see some things. You with me? Okay. This time, I will write above it. Okay, same shape. Remember, my picture is not to scale. I'm drawing it big for, I don't know, because I want, there we go.
Not
Okay.
actual size.
Yeah, so we can see it better. Okay, now look. This time, my axis of rotation is the line y equals 0.1.
Oh, that's not.
Oh.
Now, first of all, I want to know how will this volume of this object compare to the last two that we've done?
Same thing when I was.
It'll be smaller.
Should be the smallest yet.
Yes.
Because this is now below the spin line, right?
Yeah.
So what did we say when something's below the spin line? What does it do to volume? It sweeps it away, right? It sweeps it away. So this is actually going to take away some volume.
There's a drill
It's gonna
bit.
be a little
Right
hollow.
It's this one actually is not going to be hollow. Wait a minute.
through that.
No.
Yeah, well,
I think so.
Just a little bit.
It should be a tiny hollow.
Oh yeah, it might be. Yeah, it will be hollow. Yeah. Yeah, it will.
Losing my mind.
No, it will, because here's what we got to realize. Look, watch this, okay? What we got to realize is that this here is going to sweep away that amount, right? It's going to get rid of that. But here's the other thing that changes too. The radius of what's staying is also a little smaller. How much smaller? 0.1 smaller, right? So we have from 2 to 7 pi ln of x minus 0.1 squared dx minus 2 to 7 pi 0.1 squared dx. Okay?
Man, my calculator's
Just do your best. Have you been here for any of the volume days? So we're doing our best.
Wait, should it be negative 0.1?
No, because you just add. You're adding it. You minus it.
Won't technically matter because you're squaring it, but I am in a second going to change some of the plus or minuses around because I want you guys to see a pattern.
There should be minus, right, for the second integral.
She is minusing it.
For, what Ben is trying to say is he's already starting to see a pattern of stuff, and he wants me to do that.
Yes.
And I am going to add that in a little bit,
Why does that matter?
but not yet.
That's correct. So we did on the last one.
Oh, no. Oh, wait.
No,
Just
because
wait.
The last one is y
You guys.
negative 1.
Ignore the negatives. Just tell me the numbers. Trust the process. There's a method to the madness. Trust the process.
30.247.
30.247.
Well, you guys
What's
sound like
the
robots,
purpose?
but pause at the exact same
What's the purpose of me having you do the decimals, right? 1, you practice typing it in, right?
3 decimals.
2, so that you can check your answers easier if you have your integral right. 3, because I want us to go back and validate the size of the volumes. You with me? Okay, now I have a weirder one for you. Are you ready? Now, before I do the weirder one,
You're gonna make it
I
this way.
first need all the talking to cease immediately. I think you guys, I can hear what you guys are saying, and I think you guys are leading to what we're going to talk about, but if you just trust the process, I'll get there, okay? I know it's hard to trust me because I have admitted I have lied to you for your own benefit before, right? But, it's like a mother, just for your own good, right? Okay, yes, she does.
It's like when you're
As a parent, I can promise you, your mother lies to you.
It's like
Okay.
when you're a child and you ask where babies come from.
Okay, yeah, okay, whatever. Okay, I'm gonna change some things. You guys,
I'm ready.
Josh, do you think this is hiding the talking that you're doing from me? Because I know what this means, okay? You're not being tricky, okay? Okay.
If she can't see my mouth moving, it's like a T-Rex.
I'm changing some things. Are you ready?
Yeah.
Okay, here's what I'm gonna change. I'm gonna change this to be minus a negative 1.
That's just adding the 1.
Oh, so did that change anything in our process?
No.
But is it gonna help you see a pattern
Well,
better?
it's like the,
Probably.
It's like the
I'm not ready for input yet.
Let her cook.
Let me cook. Is that a good thing?
Yes.
Okay. Okay. Because somebody called me op the other day and I thought it was like some transformer op thing, but now I guess it means like opponent. It's like, so you're telling me I'm your nemesis? And it was a whole thing.
In
Okay.
this world, it's cook or be cooked.
So be cooked is good?
No, be cooked is bad.
Okay, yeah. Okay. I'm gonna put that there.
I accept that.
Is that gonna change anything numerically?
No,
But is it gonna help you see a pattern better?
maybe.
Okay, I'm gonna add something else even. Are you ready? Are you ready? Are you ready?
All that in bag of chips?
No.
Oh, that actually sounds good. Bag of chips are good.
I think so. Oh, what?
Oh, I don't like where this is going.
Now, that comment, Jalen, tells me you might foreshadow where this is going. So tell me why you don't like where this is
It
going.
just looks more complicated.
Well, because don't we like to try and get patterns from easier situations?
Right, the zeros that act.
Wait, I'm not ready yet for input.
Okay.
I believe you, Charmaine, and I.
I'm not ready yet for input.
Where'd the tie go?
Thank you.
Miss Summers, has anybody thrown a pen at you before?
No.
Do you want to be the first?
I did have somebody ask to go to the bathroom with a paper airplane last week, and it made me laugh so hard I spit out water.
That's funny because some teachers would like go freaking berserk on that.
Like, if you could surprise me with something like that, I've been teaching 15 years, like, it was pretty funny. Like, I gotta tell you, this is the first time I've been asked to use the restroom with a paper airplane thrown at my head. It was pretty funny. Yeah. One of the funniest things a student has ever done is I loved it so much because the amount of effort it took to do it. They went to DI, got an old school rotary phone on like a 30-foot cord and put the phone in the pocket back there and kept the rotary part in their backpack and didn't say a word, and it was so funny. It's so fun. Anyway, none of that matters. You guys are not helping us get through this lesson. Stop it. Stop it. Okay, I know what you're doing. Doesn't mean it won't work because I have severe ADHD, but I know what you're doing. Okay? Now hold on. Let's pause. Tell me, I added 2 things to these so far, right? I changed 2 things, not 1. Okay? Tell me about the weird negative thing I did. Tell me what do you think that's implying. Tyson.
It's implying that like whatever you have, it's like kind of the same thing and similar to me as like the top minus the bottom function kind of thing. It's always going to be minus the function or like whatever. I guess in this case the rotational axis.
Yeah, you gotta be careful because what you're saying is actually the right thought on the 0 that I added. Okay? But let's stop there. Go. I want you to come back to what the negative thing I added.
Is it because like a length or distance can't be negative?
No.
The radius length?
No, that's not what we're dealing with because the thing is going to be squared because it's radius squared. So that negative thing I added won't actually make a difference on if it's positive or negative. But let's pause on that really quick. Could our answers ever for this situation ever be negative?
No.
No, volumes like area, it must be positive, okay? Keep going. What do you think me adding the negatives where I did, right, when I changed this addition to minusing a negative, what do you think that did?
Does it show like the volume you're like adding to the equation?
Nope.
It shows you being taken away.
Nope. Well, yeah. What am I trying to get you to see in the formula? I'm trying to get you to see something in the formula.
Consistent negative.
Nope.
Always no consistent negative.
That it's like absolute value.
Minus
Nope.
the y
The y value? What y value?
value? Or like the rotation.
There it is. I'm trying to get you to visualize the axis of rotation in the formula. Okay? I'm trying to get you to visualize the axis of rotation
And that's what's like that.
exactly as it is in the formula. You with me? Now, what did the 0 do? What did the 0 do?
It showed the axis of origin.
Nope.
It's the center of the piece.
Nope.
Well, it is, isn't it?
I don't know.
Well, think about it. If you
Shows the bottom function,
There it is.
which is a straight line.
It's the g of x. Remember f of x and g of x? Remember on the blue one I said this is the first one that because it had a thickness to it, there was a top function and a bottom function? Right?
Second equation is like could be like x squared, theoretically.
It could be anything. In fact, we're going to do some
You
eventually.
can rotate it over a function.
So what I'm trying to get you to see with this, yes, you can rotate it over a function, but that's Calc 3 stuff. We're not doing that. The rotation axis is always a number for what we're doing. Oh yeah. Yeah, you can, that gets into 4-dimensional
It's
stuff.
like civil engineering.
I know.
I think, I don't know.
Okay, guys, stop. Stop. Okay? So in each of these situations so far, I have given you a g of x that's 0. Right? A g of x that's 0. A g of x that's 0. You with me? And I've given you an f of x that's ln of x. Right?
You threw us in the shallow way, as we were saying.
Oh, yeah, when we're about to jump off the, not the high dive, the middle dive. We're about to jump off the first diving board. Okay, the one that's like 1 foot above the ground. You with me? So, now, you guys, this will only work if you follow my instructions perfectly. You with me? I'm going to give you another one. And here's what I want you to do. You with me? Step 1, decide how the volume should compare to all of our ones so far. Okay? With me? Step 2, you can use your calculator. No, you cannot use your calculator at all yet. That's the next part. Step 2 is write the integrand first. Don't type anything into your calculator until you've tried to write the integrand and understand it with your neighbors. Okay? Don't pick up your calculator until you have a full integral written out for it. Does that make sense? That's the only way things are going to come together is if you do it in that order. You with me? First, decide how the volume should compare. 2, write the integral. 3, type it in your calculator. 4, validate the answer from your calculator. You with me? Okay, so here's the last one we're going to do of this shape. Okay? I have the same f of x and the same g of x. Okay?
Okay. Gotcha.
Here's my axis of rotation.
Is this told you to zone?
Yes.
You telling me if the g of x is...
Don't worry about anything. Don't just stay on this problem right now. Rotation is y equals 10.
Wait a minute.
The graph doesn't even.
It gets there eventually.
It's gonna be an inside out.
Well, it doesn't matter if the graph gets there eventually or not at all or ever, right? It didn't get to some of these others. It doesn't matter.
Is it gonna be a big hollow thing in the middle?
Hold on.
It's inside out.
This is what you need to do. You need to decide if the volume is going to be, how it's going to compare to the one so far. If you think it'll help you to try and sketch it, you can, okay? Because you basically need to decide what's different about this one. Then you need to try and write an integral, then type it into your calculator to validate it, okay? So you've got a couple minutes to do that with your neighbors.
What's different about this one? It is being located above the
Thank you. Order.
In the 2 to 7 domain,
Method of
it
madness.
doesn't.
Hey, your doodles.
Does it create a...
I know, Jackson.
It might create a spiral.
Well, I'm recording it today, and I know because they were very
Thinking if I flip it
oriented.
one way,
But
and I have to
it
flip
would
it
be,
back the other
I
way,
think I
it's
posted
hard
some
enough.
videos. Didn't I post some videos?
So it's like a...
From 80 classroom videos? But didn't I post outside this? I thought I posted one or two. Yeah, I think I did. But of all the stuff, Jackson,
Kill it.
this stuff is like, how do I say it? It's gonna be really easy to find stuff about this. This is like the famous calculus stuff that we're talking about, you know? Yeah, and cross sections. Yeah. You could literally type in calculus cross section volume and you see it pop up. This is one of the most like.
So the g of x would take the place of the f of x because g of x would be on top instead of f of x.
It could be.
We don't have them to borrow out.
Maybe minus 10, right?
So you can rent one from the school, but you don't provide them if you don't have one. Do you not have a graphic? Do you not have one all year? No? Are you a junior? Senior? Okay. So what did you do on your ACT? Did you just borrow one on your ACT? Oh, duh. Okay. Yeah, the school rents them for $25 for the year, or you could find like a buddy that maybe you could borrow one from. I'm sorry, we just don't. What is this? A noodle? Looks like a macaroni noodle. Oh, I was like, did you make me macaroni art?
Yeah, I got.
Ah. Winning. Why is yours a different color?
Stop. Collaborate and listen. Back to
I think I got it first.
Should not be negative. Volume can't be negative.
Oh, that's why.
I think I got it. It's bigger still.
It's a black hole. So the volume is yes. Exactly.
Also, it's not a calculator, I don't think.
If you want to write the integrand, you can.
Oh, okay. Never mind.
Okay. If you got a negative answer,
Does that mean we did it wrong?
yes.
I think I.
If you got a negative answer, there is something wrong with your integral.
Yeah. You close.
Okay?
You might got this, guys.
Stapleton, you guys think you got it? Come up and write it. I'm going to try and draw the picture.
What'd you get?
We're in the integral right now.
500.
We were
Okay.
just trying to figure out the shape it would make.
Oh, okay.
No. We know how to write
The shape that it makes reminds me of, have you guys been to the aquarium lately? You know the thing that they, you throw the quarter in? Oh, yeah.
I love
I
that
think.
thing.
To me, I don't know, that's what I think of when I think of this
I
shape.
think I know what it is.
What is it?
Oh,
do the answer?
Yeah.
Like the integral?
Yeah.
Come write it up. Or like a whirlpool, or I don't know. For some reason, I always think of those things that you throw the quarters in and they go.
Oh, wait a minute. It's top minus the bottom.
I think I got something.
We'll talk.
This is negative.
Now,
Basically, except he did L and minus 10,
perfect.
which I didn't do.
Won't matter because you're squaring it. So 10 minus ln or ln minus 10 is squared. That's not the part that makes it positive or negative.
Yeah, I didn't even include the L in there. That's what.
Now hold on. Let's look at what's different about this one. What's different about this one is that the part that's being taken out is not a nice cylinder. Like, you guys, up here. The part that's being taken out is not a nice cylinder like on the other ones, right? The cylinder this time is the outside part. And the function is what is being taken away this time, right? Here is the x-axis, right? Okay? Now, let me ask you this. First of all, before you even tried it, did you decide how would this volume compare to the ones we've done so far?
Yes.
Has to be the biggest yet.
Yeah.
For sure the biggest yet. For lots of reasons. One reason is because it's furthest away from the axis of symmetry so far, right? So it's even the most outside lane on the track, right? Okay? This is the sidewalk around the stadium, right? It's way bigger than the other ones, right? Okay? The other reason is because the larger function this time is like a straight line. I mean, when you want to maximize any kind of area, you don't want circles and you don't want circles and curves, you want squares and rectangles, okay? Now, with that in mind, notice that I'm still minus 10, I'm still minus 10. You with me?
Shouldn't that be plus?
No.
It should be minus
Why
1.
did we do that on the other one then?
The one that I
Minus
changed the
minus.
plus to be minus and negative 1.
Minus.
But this one is.
You with me?
Yeah.
Now, if you had done 10 minus ln of x, it makes more sense in your head that way, because you're thinking, oh, the 10 is above, that's fine, right? Okay? But the key part, because it's squared, it won't matter. You with me? But the key part of this is, guys, the key part of this is the 0, the g of x, had to come first. Why?
Because it's the top function.
It's not the top function.
Well, according to the rotational axis.
According to the rotational
Well,
axes,
in
these
relation.
y coordinates are bigger than this.
No.
You guys are thinking about it. Listen, you guys are thinking about it in your head correctly because you're imagining the spin. So if it's spun on top, it'd be the top function, right?
Yes.
Okay, but it's technically, if I'm saying the top function with our definition of top function, meaning larger positive y coordinates, it's not the top function.
Y equals 10.
It's the furthest
That's what I
function.
said.
It's the furthest function.
Why isn't it top?
Because 0 is less than anything on the ln of x.
No, we're saying we have y equals 10.
Well, I've already talked about that. I've talked about the 0 and the ln x right now. Why the 0's first, okay? So the 0 has to come before this one this time because it's further away from the axes, okay? So it's creating a bigger volume, okay? So with area and with cross-section volume, our f of x is the top function, our g of x is the bottom function. With rotational volume, f of x is the function furthest from the axis of rotation, and the g of x is the function closest to the axis of rotation. I'm going to write that again when I write the formula in a second, but I want us to try a new problem, new function, new all of it. You with me?
Yeah.
Does anybody have any questions so far that they want to ask before we round it out? It's coming together? Good. Okay.
I feel like I make a connection and then it disappears.
No, Denali, you gotta be positive.
No, I am being positive.
Okay.
I'm saying I make connections, but then the connections like unconnect, but they disconnect.
Look at
It's
it.
like my control is
This one would be.
I get that, but that's not
That is positive.
We need
because
to
at
swear
least
him,
I'm
make him
making
positive.
connections today.
Oh,
In general.
We need to square him. Yeah. Okay. So here, I'm gonna give you a new function. Okay? And you guys are gonna do the whole thing with me. And I'm gonna give you 3 different ones I want you to find. Volumes with the same new function. Okay? Sound okay? In fact, I'm gonna do over here so I can write the equation up. Okay.
This looked like the homework just
Yeah, with cross sections, right? Don't trust the picture, it's all the same shape.
It's the onions.
Yeah. It's the onions, but without cross sections.
That's on recording.
Okay, so the 2 equations being used the whole time, I'm not going to tell you which equation is which, and I'm not telling you their intersection, I'm not telling you anything besides the 2 equations.
You can use the calculator? No.
Yes. But you have to set up the integral. Just so you guys know, a lot of times on non-calculator FRQs, they'll have you set up an integral like this, and it'll specifically say, do not solve, because it's too hard to solve without a calculator, right? But that's why it's important you know which order the pieces should be in, so that if I did type it in, would it be positive or negative, right? Does that make sense?
Yeah.
Okay. Okay, so one of the equations is going to be,
Pi 2. Is that like pi 2?
No. It's x over 2. Yeah.
uh-huh.
Oh, I know which one's which.
Oh, axis of rotation is always defined as the k value, just FYI. So, those are the 3 different ways they could say that one.
I would say AOF.
So I want an integrand as well as a decimal to 3 decimals. The only hint I'll give you on this one is you may want that calculator storing thing that I've mentioned in the past.
I don't remember.
Wait, no. Taco Bell.
Is that x over 8 or x over 2?
So this is how DNA.
Oh, or is it 6?
What? Oh, this is x over 2.
Oh, okay. Doing all this.
So much cosine in me.